Hello all, welcome back to another video. So we have already seen in the previous videos about the various tests that are conducted in field and by which we collect soil samples from the field. Now the collection of soil samples or the sampling process is extremely important in order to determine the index and geotechnical properties of the soil. So this video is all about the whole process of sampling of soils or collection of soil samples from uh, the site from various depths as required, and also we'll look into the types of samplers used for collecting the soil samples. So soil sampling, it's actually the process of obtaining soil samples from the desired depth at the desired location in a natural soil deposit. And the whole purpose of collecting or obtaining soil samples from various depths is to assess or determine the soil properties, both index properties as well as engineering properties of soils. Only then a proper assessment regarding the suitability of a soil for its use in foundation can be found out or can be determined. Now, the instruments or the apparatus which is used for collecting the soil samples or for retrieving the soil samples from various depths, those are called as soil samplers. Okay, the whole process of collecting soil samples is called as sampling, and the instruments or the apparatus used for collecting the soil samples is called as a sampler. Now, there are different types of samples. Okay, so it's basically dependent on the degree of disturbance caused to the soil sample. Soil samples can be classified as either disturbed samples or undisturbed samples, and disturbed samples are those samples. In simple terms, we can differentiate between disturbed and undisturbed based on the natural structure of the soil sample. Okay, so if the natural structure of the soil sample is disturbed due to the sampling operation or boring operation, then we call such samples as disturbed samples. And using such disturbed samples, it is not suitable to assess the engineering properties of the soil, such as shear strength, consolidation, or permeability. Because for assessing engineering properties, we need undisturbed samples. So using disturbed samples, we mostly assess only the physical or index properties of the soil. Now, disturbed samples can further be classified as non-representative and representative samples. Uh, Now, non-representative samples means in some cases the soil samples would contain a mixture of mineral constituents. Okay, so those mineral constituents will not be pertaining to the soil sample from a certain depth. It could have been mixed up with the soil from the other stratas as well. Okay, so sometimes from the mineral constituents of the both the soil strata as well as the rock strata could have got mixed up due to some processes, and when the mineral constituents of the soil sampled collected does not really represent the true mineral constituents of that strata, then those samples are called as non-representative soil samples. Okay, so such samples can only give some qualitative information like the major changes in subsoil strata and all, whereas representative samples means here also the structure of the soil is definitely disturbed, but the soil sample collected would have the correct mineral constituents of the sample collected from that particular depth. Okay, so basically representative and non-representative samples are classified as such based on the mineral constituents present in it. If the mineral constituents present in the soil sample represent the correct mineral constituents of the soil collected from a particular depth, then it's a representative sample. Then using that, we can correctly determine all the physical properties. Non-representative means when the soil mineral constituents, when the mineral constituents from two different strata have been mixed up in the sample you have collected and the structure is also disturbed. Such samples are called as non-representative samples. Now, the second type of sample is an undisturbed sample. Obviously, it's a very good quality sample and we require undisturbed samples for determining accurate values of engineering properties of soils. So here, the structure of the soil uh, will not be disturbed. Okay, see, even when we say disturbed and undisturbed, it's a relative term only, because in the true sense, even with the best boring technique or with the best samplers used, some degree of disturbance will definitely be caused to your soil sample. Okay, so it's not a purely undisturbed, but it's a comparatively undisturbed sample that we are talking about. Okay, so here the structure of the soil remains intact, so we can use such undisturbed samples for determining the engineering properties. Now, such samples are also called as, the undisturbed samples will either be tube samples or chunk samples. Now, um, basically how we obtain these chunk samples and all is that, at the bottom of the pit, you can just simply, if cohesion is present in the soil, you can just simply, collect the soil sample and then drive a open-ended cylinder. Okay, you should use a cylinder whose both ends are open. Then drive that open-ended cylinder into the chunk of soil sample collected at the bottom of the pit. Okay, and then one side of that cylinder can be sealed using wax. Now, one side of the cylinder is sealed. Okay, now at the bottom of the pit, what you can do is you can just insert a spatula. Okay, so in this way, you will be able to retrieve the soil sample into this one end closed cylinder. So those are called as chunk samples. Tube samples basically obtained by means of some tube samplers, good quality tube samplers. Now, samplers can be classified based on two main criteria, either depending on their area ratio or depending upon the mode of operation. Now, depending on the uh, area ratio is a very important factor which determines the degree of disturbance caused to your soil sample. Now, this area ratio, based on that, we can classify samplers as either thick-walled samplers or thin-walled samplers. And if the area ratio is greater than 10%, it's a thick-walled sampler, and it can even go up to 30% also. Now, when the area ratio is less than 10%, we call it as thin-walled samplers. And mostly for the thin-walled samplers, the area ratio ranges between 6 to 9%. Okay, so one example of a thick-walled sampler is a split spoon sampler, and you have already heard about split spoon sampler in standard penetration test, because in the standard penetration test, the penetrometer used for driving into soil was the split spoon sampler, which will help in retrieving the soil sample from that particular depth as well. Now, one example of a thin-walled sampler is a Shelby tube sampler. Now, for getting undisturbed soil samples, this area ratio should be less than 10%. Now, the second classification is based on the mode of operation of the sampler, and that is with that criteria, the samplers may be further classified as open drive sampler, stationary piston sampler, and rotary sampler. So based on the mode of operation, you have an open drive sampler. Now this sampler can be simply pushed or driven into your ground for collecting the soil samples from the required depth. Now once the sample has entered inside the sampler, in order to detach the soil sample from the ground, this sampler simply needs to be rotated. Okay. And these samplers are also provided with valves so that the air and water which has entered while driving into soil can escape quickly from the soil samples. Also, these type of samplers can be made as a thick-walled sampler or either as a thin-walled sampler. So, based on the requirement of getting either an undisturbed or disturbed soil sample, we can use either a thick-walled open drive sampler or a thin-walled open drive sampler. And these tubes, as you can see, these open drive samplers, it can be made as a seamless tube, that is like a one piece tube, or as a split tube. Okay, that is, split tube means you can split this entire cylinder into two parts. In such cases the sample retrieval will be quite easier. Okay, and one example of a split tube open drive sampler is a split spoon sampler, that is the penetrometer used in standard penetration test. Now, to facilitate easy driving or pushing into your soil sample, the bottom of this sampler will be sharpened to form a cutting edge. Okay, and the other end will be machined or it will be provided with threads so that the drill road can be attached to the top end of these samplers. Okay, and the bottom end will be sharpened to form a cutting edge. Next is piston sampler. Now piston sampler consists of a cylinder as well as a piston, and there will be a piston rod attached to this piston, and then the drill rod will be attached to this piston rod. Okay, so while the sampler will be first lowered into or up to the desired depth where you have to collect the soil samples. Now while this is being lowered, the lower end of the sampler is kept closed with the piston. Okay. Now once you reach the desired depth from where the soil samples is to be collected, then the piston rod will be clamped. Okay. So thereby the piston will be stationary. It will not move. It will not have any motions any further. Then what happens is that once the piston is kept stationary, this sampler tube will be advanced into the soil. Okay. Then the sampler is lifted after retrieving the soil sample and the piston rod clamped in position. Okay, so this piston actually prevents the entry of the water and soil into the tube when it is being lowered, and also it helps in retaining the sample during the process of lifting the tube. Okay, now using piston samplers, sampling in soft soils and saturated sands become much easier. Now, the third type of sampler is a rotary sampler. Here, it's a double-walled sampler. You will have an inner wall as well as an outer wall. So, the outer wall or the outer tube, that is the main part. Okay, that part, the end of this outer tube will be provided with a cutting bit. So, this outer tube with a cutting bit is what is driven into your soil by means of rotating, and the inner tube will remain stationary itself. A removable liner will also be provided inside this tube. Now as the outer tube rotates into your soil sample, the soil sample will be collected into the inner tube. Okay, and these types of samplers are suitable for collecting soil samples or rock samples also. So soil samples, particularly in firm to hard cohesive soils, rotary samplers will be quite useful, as well as we can use the same sampler in rocks as well. Now there are many factors which causes disturbance to the soil sample which is collected into the samplers. Now mostly those factors are related to the sampler dimensions and its characteristics. So the main design features of a sampler which causes or which has a possibility of causing disturbance to the soil sample are: the dimensions of the cutting edge as well as those of the sampling tube. So in the figure shown here is a sampler tube at the end of which a cutting edge is also provided. So this cutting edge basically facilitates in driving into the soil. So the main dimensions that governs or that decides the degree of disturbance are the inner and outer diameter of the sampler tube, which is represented as ds and dt, as well as the inner and outer diameter of this cutting edge, which is represented by dc and dw. So basically these dimensions to some extent decides the degree of disturbance caused to the soil sample collected into the sampling tube. Now, the other factor is the characteristics of the non-return valve, which is part of the sampler. And then the third factor is the wall friction inside the sampler. Now, in addition to these characteristics, the method of sampling also affects the sample disturbance. So let's look into the various factors one by one which causes sample disturbance. Now, the first factor is related to the dimensions of the cutting edge as well as the sampling tube dimensions. Now there are three parameters which can be found out based on the dimensions of the cutting edge and the sampling tube. Now using the values obtained for these three parameters, the degree of disturbance caused to the soil sample while using a particular type of sampler can be assessed. So those three parameters which can be found out using the dimensions of cutting edge and sampling tube are area ratio, inside clearance and outside clearance. Now area ratio, it's basically the ratio of the volume of the soil displaced to the volume of the soil sample collected. Now to a great extent it is this area ratio which decides on the degree of disturbance caused to the sample. And in the last slide we also saw that the samplers itself are mainly classified based on area ratio as thick walled samplers and thin walled samplers. So if we want to obtain a very good undisturbed good quality sample, then we have to keep the area ratio as minimum as possible, and by criteria area ratio should be kept less than 10% to obtain a good quality undisturbed soil sample. Okay, now area ratio is calculated in terms of the dimensions of the cutting edge. So dW is the outer diameter of the cutting edge, whereas DC is the inner diameter of the cutting edge. So area ratio is dW square minus DC square by DC square into 100%. So as I said, area ratio, based on area ratio, if the area ratio is greater than 10%, the samplers are called as thick walled samplers. And using thick walled samplers, when you use thick walled samplers with area ratio greater than 10%, some disturbance will definitely be caused to the soil sample. But when a sampler with an area ratio less than 10% is used, the degree of disturbance caused to the sample will be very low. Now, talking about inside clearance is actually it's designated as CI. It can be found out by the equation ds minus dc by dc into 100. Now ds is the inner diameter of the sampler tube and dc is the inner diameter of the cutting edge. So basically by means of inside clearance, what we mean is that when the cutting edge drives through the ground, the soil sample will be entering this sampler tube. So when the soil sample enters the sampler tube, it should be experiencing very low frictional drag, which is provided from the walls of the tube, as well as the tube clearance should be such that the sampler tube clearance or the inside clearance should be such that naturally there is an elastic expansion of the soil sample entering into the tube. Okay, so for getting a good quality sample, as well as the sample should be able the sampler should be able to retain the soil sample within it. It should not just slide out of the sampler. Okay, so once you are driving into the ground, the sampler enters soil sample should enter the sampler tube with least by experiencing very low amount of friction from the sides of the sampler tube, as well as there should be an easy expansion of the soil sample while entering into the sampler tube. Okay, so the inside clearance should be such that the soil sample will be retained very well within the sampler tube itself without falling down, as well as it will be undergoing very least amount of disturbance also. So for getting a good quality undisturbed soil sample, this inside clearance should be in the range of 1 to 3% and not more than that. And third is outside clearance. Outside clearance is basically found out using the outside diameter of the cutting edge DW and the outside diameter of the sampler tube DT. So it's calculated as dW minus dt, the whole divided by dt into 100. Now outside clearance actually facilitates, it should be such that it facilitates the withdrawal of the sample from the ground. When you are trying to retrieve the soil sample, this outside clearance should be such that there is an easily the sample can be withdrawn from the ground. And this for a good quality undisturbed sample, this outside clearance should not be much greater than your specified inside clearance. Okay, so this is so based on the values obtained for each of these parameters, we will be able to assess the degree of disturbance caused to the soil, or a degree of disturbance which can which the soil sample will undergo if a particular sampler is used. Okay, the next factor is a wall friction experienced inside the sampler tube. Wall friction should be as low as possible in order to get good quality undisturbed soil sample. So to reduce the friction, we can always oil the inside of the inner side of the sampler tube walls and to keep the disturbance to a minimum level. Then the one thing regarding the non-return valve is that it should have an orifice large enough to allow the air and water to escape quickly and easily when driving this sampler. Okay, then the last factor which governs the disturbance cost is the recovery ratio of the sampler. Now recovery ratio, that is basically the ratio of the length of the sample obtained to the depth of the penetration. That is, out of the total depth the sampler has penetrated, how much soil sample were you able to recover out of the total depth. Okay, so that determines the amount of retrieval which was achieved during the sampling process. So if the recovery ratio is 96% to 90%, it means you have a very good undisturbed soil sample. So lastly, we'll just look into what a split spoon sampler is. Now this is an open drive type of sampler. You just need to simply push or drive the sampler into the ground to collect the soil samples. Also, it is made as a thick walled sampler and a split sampler. Okay, that is, this whole cylindrical tube can be split into two halves. So that actually makes the process of soil sample retrieval quite easier. Now the basic dimensions, that is the internal as well as external diameter of this sampler is 35 mm as well as 50.8 mm, and it will have a cutting edge. This split spoon sampler has a cutting edge attached to the bottom of the sampler portion, I mean the tube portion, so that easy driving is facilitated, and it will have a sample head which is screwed at the upper end of the split spoon. Okay, so this split spoon sampler will be lower to the desired depth from where the soil samples will have to be collected, and then this will be simply pushed into the subsoil. Okay, and we have seen the use of split spoon sampler in standard penetration test, and widely it is used in as a penetrometer for standard penetration test. So it not really uh, just penetrates into soil, but also helps in collecting the soil samples from the depth at which the SPT was conducted. Okay, now once you have collected the soil sample into the sampler, this whole assembly of the sampler will be taken out of the hole. Okay, and then the cutting edge can be removed, as well as the other top end of this sampler will have a coupling to which your drill rods are attached, so that can also be removed, unscrewed and removed. So you will be able to get the sampler tube alone. Okay, now as the name suggests, it's a split spoon sampler, so you can just split this whole cylindrical tube into two halves and then easily retrieve the sample. Okay, so once you retrieve the sample out of it, we have to put this soil sample carefully in a glass jar and seal it properly. Now before, all these samples have to be taken to the laboratory for their property determination. So the samples should not be disturbed at all. So as it is obtained from the sampler, it has to be taken out and carefully put in some jar and sealed. Okay, or in some cases, what we can do is we can put a liner inside the split spoon sampler and retrieve the sample out of this split spoon with the liner itself, and then seal both sides with wax, so that completely it becomes a moisture proof sample, and then it can be transported to laboratory. Okay, so not only is the collection of the soil samples important, but also the handling as well as the transportation of the soil samples is also very crucial um, to causing very least disturbance to the soil sample. So that also has to be given extreme care, that is especially during the handling and transportation of the sample. Extreme care needs to be provided to these soil samples. Okay, so that's all about your sampling process and the types of samplers. So thank you.